Hello viewers, welcome to my channel Knowledge Unlimited, and in this video I am going to explain about a standard second order system. And this is a very important concept, and all the formulas that you are going to find, you will get maximum problems on the standard second order systems only, and it will take 4 to 5 videos for me to cover the complete topic about the standard second order system. So in this video I am going to explain how to find the transfer function, and I am going to derive 2 to 3 relations that are very important that one should note from this standard second order system derivation. So let me draw the circuit for you. That is a resistor. Since it is a second order system, there should be two poles. I already explained what is meant by pole and what is meant by zero, and in the end of this video I will make you to observe that we will end up with two poles here because it is called as second order system. So here I will give my input, and here you have to take your output across the capacitor. So this is my inductor and this is my capacitor. Now as you all know that the transfer function means transfer function equal to output by input. In general, I explained why we consider the transfer function in S domain, because it is easy to calculate and to estimate the poles and zeros. If you want, you can see for further explanation my previous videos. Now I am going to explain here. So now let me write itself in S domain here. So R will remain as R in the Laplace transform also. L will become j omega L, that is equal to SL, and C will become j omega C, that is 1 by SC. Now the transfer function equal to V output in S domain by V input in S domain. So it will be from the voltage division rule, you can directly write V output of S equal to V input of S into C. For time being you neglect V input of S here. Why? Because I am writing here. Now the output voltage here equal to input voltage into this impedance, that is 1 by SC divided by the total impedance. Here the impedance is in series, so I can add them all, that is SL plus 1 by SC. Now you can take LCM in the denominator. The numerator will be 1 by SC, and in the denominator you can write it as SRC plus S square LC plus 1 by SC. So now you can cancel SC and SC in the denominator. So now I can write finally it as 1 by S square LC. I am writing the S square term first, SRC plus 1. So now if you observe, I am going to divide this LC term throughout the equation. So here LC will get cancelled, and here I will get LC in the denominator, and here I will get LC in the denominator. So here also I will get LC, because the operation should be carried out in both numerator and denominator. So now from this point you can write this equation as 1 by LC by S square plus S into C, and C will get cancelled, R by L plus 1 by LC. Now let me consider some assumptions here. That is, let me consider 1 by LC equal to omega n square. Don't worry about the new term, that is omega n. I will explain you in short time or in the next video. This is called as the omega n. Then from this omega n will be 1 by root LC, and this omega n is called as a resonant frequency for RLC circuit. Since we considered in the question RLC circuit, This 1 by root over LC is called as the resonant frequency for this circuit. You all might know what is resonant frequency. This is the frequency at which you will get the maximum value. So this is called as resonant frequency, but time being you just remember 1 by root LC as omega n. So 1 by LC will become omega n square. So I can replace both in numerator and denominator in the place of 1 by LC with omega n square. And now there is one more term that we have to take care, that is R by L. So now I can write R by L as 2 zeta omega n. For time being you just remember this term also. Now I will explain why I wrote as 2 zeta omega n in the coming videos. For time being I am trying to derive all the formulas that are necessary to do further analysis on the standard second order system. So you came up with the two new terms, that is zeta and omega n. For time being you just remember zeta as a damping ratio which plays a major role in the complete topic of time domain analysis, and omega n is called as a natural frequency. So I think you are not satisfied. Why? Because I just wrote these names, but in short time I am going to reveal why we call this as natural frequency and why zeta is called as damping ratio. To give you a small introduction about this, while plotting the analysis, we will get some plots like this. So the frequency with which the wave will travel is called as natural frequency, and by the derivations we will have the term omega n involved in that. So we call omega n as the natural frequency, and the zeta is the factor that decides the damping of the function, whether it is over damped or critically damped or under damped, and several other cases we are going to consider soon. So that is why zeta is called as the damping ratio. So now I told you that omega n equal to 1 by root LC. Now you can substitute omega n here. So R by L equal to 2 times of zeta into omega n, that is 1 by root L into root C. Now I can cancel L and root L, and here I will get root L. So finally zeta equal to, if you bring this to this side, it will be denominator, so R by 2 into, and the C will come up, root over C by L. So this is the way to calculate the damping ratio zeta. So now from this you can conclude that the damping ratio of the system or the type of system is completely depends on the components. It depends on the components that you are used in the design. So how high precision components you are used, that is the better, then you will get the better quality system or the best system you can design from the root, that is by using efficient components. So in this way the damping ratio is completely depending on the components, and here you can see the natural frequency of operation also is solely depending on the components that you are using. So now in the place of R by L I can write 2 zeta omega n, and 1 by LC I can write it as omega n square. So now I am rewriting the transfer function by necessary assumptions, that is omega n square by s square plus 2 zeta omega n plus omega n square. So this is very important in the entire control systems, and we often deal with this equation for the next 5 to 10 videos, and this is the basic the transfer function of a standard second order system. So this is the transfer function of standard second order system, and from this we are going to derive few more relations. And now you can see that we can draw one more figure here itself. So this is the transfer function, means I can consider it as a closed loop system equation. I already explained what is closed loop and what is open loop. Now you can get the open loop representation, the block diagram representation from this easily. That is the numerator will remain as it is, numerator by denominator minus numerator. So you will get s square plus 2 zeta omega n as the open loop transfer function block. And if you give here, you will get output a negative feedback, a negative unity feedback. Then from this you can find the closed loop transfer function by g by 1 plus gh. I already told you the block diagram reduction technique rules. So now g by 1 plus gh, if you simplify, you will get omega square by s square plus 2 zeta omega, and here I didn't wrote s here, it will be s. So you can write it as omega n square by s into s plus 2 zeta omega n. This is the open loop transfer function of the open loop transfer function of second order system. So in this way, with all these formulas, now you can get start with the standard second order system. Now in the next video I am going to explain 2 to 3 examples on calculation of type number, how to calculate the type number of the system. Type number, you might think it is easy, but I am going to explain 2 to 3 problems that are given in GATE, which are very tricky, and I think 90% of you will do it wrong for the first time. So that's all for this video. Hope you guys enjoyed a lot, and please subscribe to my channel and click on the bell icon to not to miss my future videos.